Hopefully you can hear me. Let me know if you can't. Let me see my check your audio. All right, let's see if you can hear me now. Can you hold on? Oh, okay. You guys can hear me. Great. So, sorry about the delay. I thought I had another set of interview questions immediately afterwards. I said, "Oh, if we go long, it's not the end of the world." I went, "No, it's you guys." I want to make sure that everything is all well and good with you guys when it comes to the assignment, which is due tomorrow night. The TAs and I both were all confused. We're like, "Is it tomorrow night? Is it tonight?" We double checked. It's tomorrow night. Just before midnight. So beyond that, though, I wanted to see how you guys were doing when it comes to. Do you want to see me open things up in Visual Studio, play with some like a new Hello World kind of thing? Let's see what you guys have to say. How are we here? Are we hearing me now, though? Right? It looks fine, I think, according to my thing. All right. So, what would you guys like to go over? This is meant to be Q&A sessions for you guys, and normally each week it's just before the assignment is due, so that it gives you an extra chance to ask questions, make sure you're unstuck, whatever you need to help you out for the assignments and for any given concept that we're talking about in class. As the course goes along, it's going to get more and more. It's going to snowball a little bit, and so I want to make sure that we answer questions right away as soon as we can. Oh, thank you. Wednesday's exam. Forgot all about that too. So I have trouble submitting the Visual Studio file, CVP file alone. When I tried opening it, it will not work alone when you open it. So that's a great. So let's go over that as well. I'll go over what's on Wednesday's exam and general question about the exam on Wednesday. I'm not sure if I missed, but I'm not sure the topics have covered. Sure, we'll go over that as well. Everyone about the exam. Yeah, and the whole point is we're not allowing zip files for let me see here. For Scratch, there is an SB3 file that you get. You just save it to your desktop, and when you go to Scratch and you save to your desktop, it'll save up in a particular format. I don't think you can straight run that. It's a scripted file that you would send back into Scratch to run it again. Same thing with Visual Studio, actually. A CPP file, a .cpp file, is just a text file. Honest to God, it sounds like it's so fancy and elaborate. No, it's a text file. You can open it up anywhere you want, but you can't run it anywhere you want. It's just text. What a compiler actually does is it takes that text file, figures out what those actual instructions mean, converts it down into bytecode, converts it into computer language, and then the computer executes that. You will get an executable, a .exe file when you compile it. One of the big problems for students, especially in this class, it's frustrating for me and for you. It's frustrating for everybody, not what you guys are going through, but everybody goes through this. What you will end up doing is you will have some CPP file. You will compile the file, or you will think you compiled the file. That's the gotcha. And then afterwards, you will think you've compiled your file. You have not, because you had some error in your code. And then you go to run it and you're running an old version of the file, especially if you turn off your errors. When you get an error pop up and says, hey, do you want to keep getting warnings when you have a compile error? And you say, no, turn those off because you're used to doing that. Everyone is. And then you go to compile, you go to run it, and you're running something you made 4 hours ago. Not the one you just made, because it didn't make. You're running something like from 4 hours ago, and you can be staring at that for like hours, another couple hours, just staring at why your code's not working as you expect. And it's because you're running an old executable, not the current code as it is. And it's quite frustrating. So a CPP file is not executable. You cannot run it. It's not a script. A CPP file is just a text file. But I'm only allowing you to submit .cpp files because if you try and zip up your entire project, it is massive. I tried this on my very first term at Carleton, thinking, "Hey, that'll be easier for students," and it's just like banging your head off a wall. It's megs and megs and megs in size. CBP file, and the person marking will be able to get it to work. Yep, they'll actually just copy the text for your assignments, especially. They will just select all, copy the text, drop it into whatever CBP file they're using, compile, and it's really quite easy to do. So it's a lot easier that way rather than this giant massive file. Okay. Yep, I can use it. C-line acceptable. Again, I made a comment on Discord today, but yeah, not everyone has Discord. C-line is risky the way driving on the Queensway is risky. It's not actually that risky, but there's a chance that things go off the rails, right? C-line, later on, you'll need to make sure you have a Windows machine for other classes, or for my 2400 class, C-line should work for the vast majority of time for this class. But there's an off chance, like, well, when we deal with scanf, for example, Microsoft, yes, it's a pain. Microsoft has their own version of scanf, or they're trying a new standard, scanf_s, as in safe or secure. And if you're writing it on a Mac, it doesn't have that function. So you write it for scanf, you send it to the TAs go to compile it. Visual Studio curses at them, tells them it's broken because you're using scanf instead of scanf_s, the secure way. On an error, it should be just a warning, but it treats it like an error. We will go over, there's just a little tag that you can plop at the top of your file to make sure that that doesn't blow up in your face when you actually run C code. So it should be acceptable for most things. For the lab, it's certainly acceptable. But for later assignments, especially later on in the term, when things get a bit bigger, you want to make sure that ideally, when it's pre-craziness times, what I would say is have C-line, and just before you're about to submit your file, that day, throw that file that you had, throw it into one of the computers at the school, and see what happens. Right? See if it's still working correctly. So what you could do is just run it on one of the lab machines, make sure the code still runs and compiles correctly, and then you're good, right? You've tried it on 2 different systems. They both compile on both systems. You're good. You didn't need a virtual machine. But you will eventually need it. But for the time being, C-line should be perfectly fine. It's just not 100% guaranteed lock, always fine. But very few things in this world are 100% lock guaranteed. So, okay, so let's go over the exam. What have we covered? So pretty much the only thing I can cover on the lab, on the exam, would be computational thinking. So I can cover pseudocode. I can cover flowcharts. Yeah, I can cover pseudocode and flowcharts. And so that's really you did not have enough time between when the lesson was and when the exam is for us to necessarily throw in numeric conversions. So no hexadecimal, no binary, no 2's complement yet. We will eventually get there. There is no C coding on the exam. It's just exam 1. We will get there as well. I have 2 questions about it. The instructions file say the same as lab 2. Okay. That's gonna have to, I'm gonna have to wait for after this to look into that. What the best person to do right now, Janae is on Discord right now, or you can just email Janae and ask him about this. He should either be able to direct you in the right direction, Mackenzie, or if it's a screw up on my part and I need to magically change everything right away, then I need to magically change things right away, and he has to tell me, as he can tell me as well. He can sort of like put a fire under me. The labs themselves are something at beginning of term, everyone's freaking out about the labs. And by the end of term, they're not freaking out enough about the labs. I just like to point out labs are there for you guys to feel, to make sure you feel confident in the material. And so in 2400, for example, sorry, hopefully this sounds a bit better. All right. In 2400, for example, I had, one of those complaints that I got from one student at the very beginning of term just this year was, well, we did stuff in the lectures. We just learned syntax and how to do things in the lectures, and then immediately got an assignment. And I said, well, the assignments are there to practice. And then I went, wait, the labs are between the assignments and the lectures. It is Lectures, see what the material is. Labs, practice, fall on your face if you need to. That's fine. There should be no injury for you trying essentially with a lab. And then when you get to the assignments, that's when you're applying it. So the labs are supposed to help you with the assignments, and we can give you answers to the labs. We will give you answers to all the labs. The format of the exam, there's normally some multiple choice. Most people do not like my multiple choice questions because I am mean for multiple choice questions. I just, it's easy enough to cheat on multiple choice. I don't like making it like, what is your name? Right? There's going to be some meat to it to really show that you understand what you're doing. But there's also going to be draw out or write out, depending on how you want to do something. Something like pseudocode, flowcharts, that sort of thing. If you did handwritten work, which you're perfectly allowed to do, if you do it, then you take a photo with your phone, you upload the file, good to go. So you can attach a photo or you can write it in a text box. Yep, submission box or PDF if you want to do it that way.
I actually have a question about that.
Sure.
So, because usually, see you learn, it like restricts you from opening up any other browsers. So let's say I scan my documents and I email them to myself. How do I access that email without like it going out from the exam?
So I'm going to find out the hard way, as far as I know, because I want to double check this one. I just want to make sure I make a note to myself. I have not designed this exam to boot you out as soon as you go onto another browser. Now, they might make that warning. It's normally for don't go doing other stuff, but I did not make a hard lockdown the way that other courses do because I know people are going to do other stuff as well. And so you don't have to go to another browser either. If you take a photo and you have access to it, if you're like plugging your phone with via USB-C cable or something like that, there are ways around it. So I don't want to make it so that people get booted out of their exam for going to another tab.
And so where do we submit these files? Because usually what we've done for all of my other courses is they have a separate submission box, just like our lab assignments. They would like set the time like 30 minutes afterwards so that students have time to upload their photos.
Oh, okay. I was not that generous, so you can upload a file in during the exam. I don't know how your internet connection is, but I also know you also don't have to you don't have to take a photo either. So if your internet connection is really crappy, I'd suggest typing it. I'm trying not to make it a tight time span. I want to make sure I also don't lose track of all the chat here going on here. I don't want to make it a tight time span, but that's my attempt at least is that you should be able to upload the file in a relatively non-glacial amount of time and you'd be good to go. Just don't take a massive number of like a 5 gig file. Yeah, you got a problem, but a normal photograph should be sufficient. The exam itself has submission boxes. Yeah, there's a submission box you can type in stuff, and then there's also you can submit a file. You can choose whichever way you want. Well, there's actually let me see. PowerPoint. I normally just do it on paper if I'm doing a flowchart. Now I can ask flowchart questions without you having to draw out the flowchart, and that is a fairly fair game thing as well. But if you're drawing out a flowchart on an exam, and you most times I think people would draw it, but you can also do like I'm thinking PowerPoint, for example. You can appdiagrams.net. Great, another example. Like Visio allows you to draw out or doodle out diagrams. Word, I think you can draw out diagrams. You just need to get your point across, essentially. Again, this is an exam, it's not an assignment. So if you have something that's slightly wrong, submit it. Make sure you submit it. You don't want to get one of those cases where, oh, I'm worried about that 1%. No, submit something. It's 5. This thing is worth 5%. It's worth the same as an assignment. It's meant to be a trial run to make sure that you're feeling comfortable with class. Normally, I'd cover a bit more material as well for this exam, but just because it started later in the term, it pushed everything back. And the reason it's so early in the term is it's before the drop deadline for you guys. That's the reason we have it there. So if you did no work, and that's not you guys because you're here, but people that do no work up to this point in time in the term, and they get to that exam and they fail it, they go, oh, maybe I should drop the class and get my money back. Great, go for it, right? That's the point of that. Uh, will it matter how much on it? I've been asking my TAs to take the exam. They don't take me up on it enough, but asking them to take the exam under exam conditions and tell me how long they take. I normally estimate if the TAs can take 15 minutes, okay, it's good for a 30-minute exam, for example. Um, because what we want is we don't want it to be a sprint for you guys, but we want it to be short enough that it's hard to cheat. Because unfortunately, that is been par for the course for a lot of these courses. Online learning is just there's this cohort of students that are cheating, and it really drives me batty. If you want to get me frustrated, can we go back? You should be able to go back and review your previous answers. I'm not a fan of the blocking you off from previous answers. I know that some people are advocating for that, but I don't think it's a good idea. Is there any specific language? Nope. So anything that is, I understand what that person is saying. I know what they're trying to do. Good enough, right? If it's doodles and circles and stuff like that, I know what you're doing. Fine, right? If it's create a variable A, assign value blank to A. Yep. If it's variable A is a number, give it the value 0 instead of blank would be better. If the value is a string, give it to like and quote rather than blank, might be better. But other than that, it's all good. Okay, so practice questions. I wanted to give you a bit more practice questions. There's a practice questions for the lab. I think lab 3 is a review, but it also includes numeric conversions because it's from last term. I just made a video this past Friday night because what else am I going to do on a Friday night? I'm a nerd. But on Friday night, I did a video for my 2400 students where we were going over the process in which you can think through a particular problem for their course, except for it was exactly algorithmic thinking. It was step by step how I would go through the process of designing my algorithm for how you parse a string, parse text essentially. And so that video is online as well for you guys. I posted that and made a link on Discord. It's also in I think it's in the synchronous lecture slides, videos on CU Learn as well. I'm also should give you more pseudocode examples. I'm not a fan of pseudocode being this formalized language. Pseudocode is this kind of crap, right? If I'm working on an exam or I'm working on a program and I'm a big fan of this and I'm going to keep on harping on this. If I am coding something, I want a pad of paper next to my desk while I am working on an assignment or working on the homework or working on the lab. Have it on for every one of your exams, right? A pad of paper to play with ideas, to jot down your ideas. The pseudocode is just trying to force you to formalize your, I thought through the problem before I started typing. The worst thing you can do is just start blindly typing, hoping to God you're going to hit the answer. You're going to waste time. When you're coding, you're spinning your wheels if you start coding first. Think, then code. You don't start cutting random things in your house. If you're mailed in a bookshelf, you don't start randomly cutting boards and hoping for the best, right? You plan, then you measure twice, then you cut once, right? You want to be very methodical about this. And people don't believe me on this one, but that is where people waste their time every single term. That's where all my students waste their time. They start coding, and then you don't want to throw away your code, which is the problem, right? You take some wrong path. I do it too. You take some wrong path, and then you want to just well, how about if I try this? And you try and shoehorn your old way into what's going to be correct. And it just, you waste time doing it versus thinking, planning, then coding. I will try and give you more pseudocode questions if I can try and come up with a couple of them. They're kind of hard to come up with without being just toy novelty things. So, for example, give me an algorithm for how you shovel your driveway. It is not shovel the driveway. It is not shovel, keep shoveling until you run out of snow. You got to move that shovel around, and having a pattern to do it is going to be more efficient. Um, every single situation always should be covered if you can. Now, there's some things you're not going to think, like you can say, I am assuming that there's snow on the ground when I'm shoveling my driveway. Otherwise, don't shovel the driveway. Or assuming that my driveway is not infinitely long. Like that's a reasonable assumption. It's not an infinitely length driveway, or that I own a shovel. Right? Those are assumptions, fairly safe assumptions to make. You can't assume. You have to think of scenarios of um, what would be a good thing for the driveway. Um, Driveway doesn't have a lot of weird case scenarios like worrying whether it's had freezing rain just beforehand, and therefore you might need some kind of like one of those garden shovels to break the ice beforehand, like something like that. That would be more of those weird case scenarios. Uh, if you're talking about you're taking all the students in the class and you're dealing with all the students in the class and figuring out their average, having a student with that does not have a student number, you can assume all students have a student number. Can you assume all students have taken exam one? No, you can't. Can you assume that all students have taken labs? No, you can't. Right? That they may have blank things. Oh, the sidewalk cleaner comes midway through. Oh, I like that. I love that. That's a great. That is actually a legitimate thing, right? If the snowplow comes by and buries your driveway in again afterwards, you have a condition at the end. That the more conditions you cover, the better the answer is. Sure. All the fact you see the assumptions you're making is the key, right? The if I'm dealing with, okay, I'm going to sum up the first, I'm going to sum up a list of numbers. Let's say that's my algorithm. How do I do that? Well, one of the assumptions I make, the length of the list is zero or more. There's more zero or more numbers. So I need to cover the cases of there's zero numbers that I'm summing up. What does that sum up to? There's one number that I'm summing up. What does that sum up to? There's a certain set of numbers that I'm summing up to. Can I assume that they're positive numbers? No, they could be positive, they could be negative. Um, if I wanted to take let's say the average of a set of numbers, what kind of assumptions do I need to make? Or what do I need to handle? One of the things I would need to handle is what if I have zero numbers? The average is the sum of all the numbers divided by the number of numbers I have. I have zero numbers. So I'm dividing by zero. It's zero divided by zero, sure, but it's still zero divided by zero. And you want to make sure you cover that scenario, right? That you don't try and divide by zero. You just say the answer is zero, right? That would be a good thing to have thought about and considered. Put a scenario down. If it's something that you think is unlikely to actually occur, extremely unlikely to occur, like you have an infinite length driveway, that's something you just put down as an assumption if you want. We're not if your TAs and I can't come up with those weird esoteric scenarios, then you don't need to. But if we go like, well, there's clearly a problem here, then ideally you would think of that scenario. Is that I'm talking around it a little bit, so I want to make sure that that's making sense. Um, so how would you make a snow fort? How would you make a slide? I'm just trying to think of weird scenarios. How do you um, hmm, I just made a quiche. How to make a quiche would be a series of instructions, but there's no loop in making a quiche. And really good questions that I might ask would be something that involves some kind of looping mechanism, right? Shoveling the driveway, I'm doing a row, and then I repeat one shovel's width down, shoveling the driveway. Yes, you should list your assumptions. Nice. Uh, all right, so I want to make sure I didn't miss anything here. And pseudocode is not this formalized thing, so that's why I can't say like this is where to go for all of your things. It's just getting practice breaking down a problem because that's what you do later. It's something that it's informal, if you will. And there's no official language. Okay. There was another question at the very, very beginning that I wanted to make sure. What's exam covering? Okay. Um, Compiling code. We did that one. General question about exam Wednesday. I'm not sure if I missed. Okay. So I definitely want to. I think I covered most of these, all the things here. Um, okay. So I don't know how you guys are feeling about compiling code, Visual Studio. If you guys have tried that yet, um, the labs. Normally, I'd have a lab and I'd go around myself plus the TAs, all of us walking around, just making sure you can compile something where like you can make a hello world basic hello world project, get your hands dirty, just because that's the intimidating part. It's that first step, and then afterwards, well, it's still intimidating, but a little bit at a time. You'll do a little bit of code, compile it, a little bit of code and test it, a little bit of code, compile it, test it, a little bit of like you do a little bit at a time. But that first time, I think it would be a good idea for people, not for the exam, but just in general now, try out making what we're doing in assignment 2 really. Try making a basic program, making sure that you feel comfortable building and making something run, because that can be a stick. You don't want to be figuring that out the night the assignment is due. No, compiling means something different. So compiling is, so that's always great questions. I like going over this. Compiling means taking your C code, the text you made, and it will convert it to machine code. That's the compilation step. And if there's any mistakes in your code, you spelled something wrong, you missed a semicolon, anything like that, it stops it dead in its tracks. What's strange, you would say, who in the hell would actually want that? And I'd say, crazily enough, a lot of people, especially computer scientists, seem to love this to the point that there's something called LaTeX. There's like a Word document that you compile. You write text and then you compile your Word document so it goes into, or you compile your document into a PDF format or your PowerPoint slide into a PDF format. You're compiling documents because, fun. Any mistake in it all prevents it from you from going forward. So when you're compiling, if you have any mistake, you have to fix every last little mistake. And that's one of the scary things about it, but you get really good at it. You just take one little bit at a time, fixing every single bug one at a time, and then compiling. That's why you compile so often. So you don't get 40 bugs, you get 2. Oh, great. So let's do that. Okay, hopefully I'm not going to screen share stuff that I should not be screen sharing. I'm actually screen sharing stuff I should not be screen sharing. So I'll let it happen anyways. I'm going to make a brand new project. Hopefully it's going to go well. So I'm making, you guys can see my screen, right? I want to make sure that I'm sharing my screen properly. Not yet, damn it. Screen share, screen share. There we go. I'm going to go back out again. All right, so I'm going to make a brand new project because I actually have my answer to one of the assignments here. I'm going to make a brand new empty project. There are hello world consoles and all this kind of stuff, but Microsoft, in its infinite wisdom, as you might, as you probably have heard at various times, they decide to put all sorts of cruft and stuff, auto-generated code in there, which means when the TA gets it, it may not work for them. So we're doing these empty projects just to make sure that when you pass it to somebody, it's going to work. Okay, and I'm just going to throw it in here. I would normally put it in a proper directory, so it's can't change it. Let's change the name to. And my keyboard is off. Okay. All right. And we're going to do that. We're going to create. Okay. And what I'm going to do here is I'm going to make a brand new source file. So I'm going to add. So I right clicked, add, and I'm going to make a brand new item. And in this case, it's going to be a CPP file. I don't want to call it source because that's a crappy name. My hello world demo file, let's say. I'm going to add this. Okay. And therefore, every single function, every single program I make has one of these things, int main. It is the start and end of my entire program. Everything is in this. Now, I'll call other functions, which then will jump over here and jump down here and jump all over the place. But everything starts and ends in main. As soon as I'm done with main, I return. When I start a main, I do some stuff, all called from main, and then I end. Okay. So, and then I'm going to return. And since I'm having it return a value, that's what this thing says. It says my function is named main. It takes in nothing at all. It's going to return a number, a whole number, an integer, -1, -17, 5, 20, not a floating point number, not a fraction or anything, but a whole, the set Z, if you want to think about the integers in mathematics, if you know your math, that's what this thing will do. And I'm going to have to figure out what I need here so for this, but I'm going to need to include some other stuff. I need other people's work, essentially. IO stream should probably do it for me. It's not we're not the ideal thing to use, but we're going to use it anyways. And here we go. Printf. That is actually, what's the F stand for in this case? I always forget. It's to print. It's not to print a file because that's fprint. Is printing format, I do believe. Formatted printing. Okay, and I'm going to say hello world. That is our standard computer science lingo. Every time we do something absolutely basic and easy, we do that. Okay, next up. I've done nothing here. I'm going to save it because I want to. And I'm going to build my solution. Control Shift B. All right, that's all I'm doing. Control Shift B, or clicking on this. And I should see it work. And I'm going to see what the people have to say about this. Okay. Standard, standard IO, standard IO.h is the better thing to do. I just knew that IO stream was going to cover the same libraries, so it's easier to, and just blanking on me. I don't have it in front of me here. So let's use that. You'll see it will make no difference. Oh, darn keyboard. Standard IO.h. That is the standard input and output header file. It's somebody else's thing. And S and it's /n at the end makes a new line. Nice. That's a line break, right? And so I could even do something like this if you want to go really crazy. Let's go crazy. Crazy. What's that do? Ah. So I want to hit that Kenzie right now. Nothing, and the other one returns an integer. Yep. The -T is for tab. Okay. So we'll even have a look at this. Okay, let's compile it. Let's see what I'm compiling it. The hotkey version of compiling. Let's run it. Let's see what we get. Should say hello world. Boom, hello world. But notice that there's this big ass space in here. It's because there's a tab there, not just a space. /T is tab. There's things I can't type on a keyboard. I need some way of typing special characters. /n, /t, / how do I make a slash? // You can do vertical tabs. You can do all sorts of crazy things with this because people are used to just writing it on a keyboard. They didn't have graphic user interfaces for the longest while. All right. So the question was, and it's a great question, what's the difference between this int and a void? And they're both, I cannot have an int main and a void main. They're two different things. They're both main. I can choose one or the other. I have one starting condition. If you play role-playing games, it's the same. Like you can have one starting character. You can choose to be a dwarf or an elf or a human, but you can't be all three. But you're going to have a starting condition. You always start off with this, your starting character, but you have to choose, right? We get to choose what kind of main we have. The reason is originally functions, this was not a function, this was what's called a method. A function from a mathematical standpoint, purely mathematical standpoint, has to return something. It has to send something back out. Cosine is a function. The absolute value is a function, right? Stuff goes in, stuff comes out. And so if I have a main method that doesn't return anything, it's not a function, it's a method. And there was a very big philosophy in C for a while, in C++, where they said, no, everything should be a function. Even if it doesn't make sense, it should be a function. In this case, the reason you do this is I could have it return 0 if everything's fine, but if something goes off the rails and horrible things happen, I return like -1, and something else can catch that and deal with that in the proper way. That's the philosophy behind it, if that makes sense. So I do int main, void main is just as valid. There's even other things you can do. You can take a whole bunch of arguments. So you'll have an array of strings, which we'll get to later, and how many of these arguments you're going to have. So you can put things into your program. When you call your program, information comes into your program to start. We're not doing that until later, but that's the third way that we have. And let's see, Jamila, what's the N for? Unless I spelled something wrong. Okay. So is that making sense? And let's do one more thing in here. Let's do, I keep on going to my keyboard that is now unplugged. Okay. And I'm going to do this. 17. Why? Because that's the F in printf. It allows you to put extra stuff in there. When we put the percentage and something afterwards, it gives us the ability to output information. And printfs are the, what's the word I'm looking for here? There's got to be a good metaphor for this. It's just like the default standard for if you're trying to figure out what the hell's going on wrong with your code and you can't figure it out, printf statement. It's a brute force of ignorance of coding. When you're coding in C and you don't know what this thing does or what the value of it is, the simplest way is do a printf statement and output what the value is at that time, so that you can go, oh, in fact, that number that I had before is actually not it, is the number 17. So maybe it's something like this. Int my num is equal to 17. And then my num is, I'm going to do this, is equal to my num multiplied by 2. Okay. And you're going, what's the value for my num? I don't know what the value for my num is. I forget. I can't do 17 times 2. 34, by the way, in case you thought I couldn't do 17 times 2. All right. But if I wanted to figure out what that value was, if I'm not sure what the hell's going on with my code, why it's not working, just have it output the value to the screen. That's the simplest, easiest thing you can do. So let's compile it again. Let's run it again. Compile. I do it separately. Okay. I have built an executable now. That's what the compilation does. It's a completely different file. It's a file called myhelloworld.exe. It's actually in this location on my hard drive right now. My hello world and in the folder debug and then the name of the executable file is myhelloworld.exe. If I go to it and I double click it, or if I just run it in the command line, I will run my program right there. It knows how to execute, it knows how to do everything itself. So I'm doing it from here, but there's no magic. It's a text file that gets converted to something the machine can use that I then run on the machine. Now I'm going to run it on the machine. Boom, 34. Hey, I can do math. Congratulate me. Oh, yay. Right? In case you weren't sure, because there's lots of times, let's do an example where it's going to be like, what? Okay, let's see. Let's see if I can do an example where it's going to make you go scratch your head. 1.1. Okay, and this is going to be a floating point number. hopefully this will make you scratch your head. And since I'm a floating point number, instead of an I for integer, I'm going to put an F for float, C for character, S for string. There are different things you put in for the percentages. And it's just all it's doing is, okay, that first thing, that F, this thing right here, I'm looking for a floating point number. The first thing I have in here after this quote is this thing here. So here's my text. And then afterwards, I'm matching up these items with the next thing, the next thing, the next thing, the next thing. Okay. I'm going to compile, always compile, then run, right? I don't assume, I don't write 40,000 lines and then try and figure it out if it works. It will bite you in the ass every single time. It hurts me to see people do because I do it too. And I know I want to be able to prevent you from going through that pain, but everybody does. You will write all your code and then you say, I'm going to test it now. And then nothing works. And you go, what's wrong with this? And then you spend 5 hours trying to figure it out. Oh, it actually worked better than I was expecting. Let's see if I can do some basic math on this one. Honestly, it's working better than I expected. 1.1 times 2. Let's do 2.2 and then divide by 2. Okay. Divided by 2.0. And that's a float. That should be F's for float at the end. Otherwise, it's double precision. That's just a nuance thing. Man, I can't make it break on me here. The reason I'm saying this is because the precision should not be right. There's some weird stuff that goes on when it comes to, well, let's do it this way. Maybe that'll break it. Here's hoping. I want something that makes us all very confused. No, that still is working. Darn you, Windows. Okay, or Visual Studio. It's doing too good of a job. And divided by 2. I'm still not going to break anything. I can't break it right now. I could use it percentile. Let's find out. One of the things I love about programming is I can talk all I want. If the compiler does something different, I'm wrong. There's no ambiguity. It's like the compiler did this. Therefore, it's not whether I think I'm right or wrong. The compiler is a great mediator. What the heck? That's a good one. I like that. That's probably going to be a better example than I was going to come up with. So very nice. I put an F at the end of the number because what I wanted is a floating point number is 32 bits. I know this because I've been doing it for 20 years. It's 32 bits. It's relatively short for a floating point number. By default, if you leave that off, it makes a 64-bit number. It makes a double. It has more precision. And so by default, they are now making them 64. But if you want to float, you have to put an F on the end. Otherwise, the precision could be wrong. Great question. And the percentage I, though, is probably going to break it wonderfully, way better than I thought. Because here we go. Why is it 0? 2 divided by 2 is equal to 0. What? Yeah, there you go. That's a nice one. I like it. What the heck happened? Well, let's try something else. Oh, there we go. Let's try, instead of this, I want a 2.0 F, make a floating point number again. Compile it, see what happens. Okay. Still going to break? Still going to break that way. All right. There's one of two possibilities with what I did before. It's either that the 2 here made an integer arithmetic and did the numbers incorrectly, or it depends on how this floating point number is being stored. But because it's a floating point number, but you're saying it's an integer, whatever the bits in the floating point number are, it's interpreting it as an integer over there, and magically it just happens to be equal, that is equivalent to 0, just how the numbers end up working. But it's accidental, and you'll get weird results if you don't do things the right way. So let's do this every time int. All right, this is what's called a cast. I'm saying no, take it from the float and convert it to an integer for me properly, and then see what happens. And we should get the proper answer, I would hope. There you go. That's for assignment 3 coming up, so in case you're wondering. But these are the kinds of things that just we're going to play with very, very soon. All right. Let's see. So that's a very, very basic program. It makes an executable. The executable could then be run. And what you're going to be doing is, well, you could even play around with this one. I think that is assignment 2, right? So let's see here. Let's put some other stuff in here. Int my I'm going to give you the first digit from that number. How could I do that? So first digit is equal to, I just want the 1. Now I don't want the hardcore the value 1. So this is some of the suggestions I was making for assignment 2. What could I do just to get that number 1, that first digit, no matter what 3-digit number I have here? Well, let's make it 4. 4, 5, 6. That'll do. Okay. How do I get just the number 1 here? I want to just do some basic math here. So, well, it is a how many digit number? It's 123,456, right? What I really want is the one's position, that position at the 100,000 point, right? I want the whatever value is at the 100,000 point. Another way of looking at this number here is it is 1 times 100,000 plus 2 times 10,000 plus 3 times 1,000 plus 4 times 100 plus 5 times 10 plus 6 times 1. Oh, is it the number of digits? It will change if we do division. The number of digits, how many bits you need to store it, that'll remain constant. But what the number is being stored is going to change. So if I want the 1 times 100,000 place, but I just want the 1, I wouldn't use a loop. That's what I was trying to hint at. We didn't even touch loops. You just purely with math, with basic math. So if I wanted just a 6 in there, how do I do it? If I just wanted this 6 right here, what could I do? Well, if I use remainder, let's say remainder 10, what would that get me? So I divide this whole number here by 10. What's my remainder that I have left over? You aren't going to get decimals though. There's no, for integer arithmetic, they're only whole numbers. So I get remainders. So let's have a look at this. Okay, that's a great point here. So let's do this. And my last digit is equal to my num mod 10. And I'm going to do a printf statement here. Let's just do it the easy way. Last digit is, and I'm going to put the percentage I in here, new line in there, and my last digit. Okay. And this thing, I'll have to go down a couple lines here because this thing is not going to be, I don't have much time, but hopefully it's, damn it. It's a new project. Okay. If I mod by 100,000, what do I get? So if I modify, do I want to modify 100,000? I can divide it by 100,000. What do I get? I'll get just that number. I don't even need to do the, or you could subtract the remainder. Yep. Um, if I want the 1, why don't I just divide by 100,000? The mod by 100,000 will give me the rest of the, will give me, let me see here, 10,000 versus 100,000. So let's have a look at what this thing is actually going to do. And I have another talk to go to, a series of questions to go through. So I have to stop soon, but by the way, I have an error. Oh, what the heck? Let's have a look at this. My expression must have, okay, unscoped enumerated type. Well, that's a weird error. What is going on with this? My num is the name of the variable. I have this thing here. I need to look at what my thing does. Okay, this is modular arithmetic. I didn't comment out the float. But that shouldn't be affecting that. This is fine. I could leave it in though. It shouldn't do anything. So why is this? Oh, but my num is also predefined. Very nice. Thank you. Beautiful, beautiful debugging, by the way. You can't have two variables with the same name. Which one do you mean? Right? One's a float, one's an int. I could have been staring at that for a while. Very nice eyes. Boom. Last digit is 6, right? It is this number divided by 10 gives me 1, 2, 3, 4, 5 with a remainder of 6. And so I'm hoping I really actually have to go. So with this being said, what I'm going to do, I'm going to be on Discord. I'm going to make sure I'm checking on Discord. But if you have any questions over the next couple days, ask. I'd rather, ask and, you go, well, I can't answer that question, then find out that you were lost or you didn't know what to do. Debugging the code is just trying to figure out what the heck's going wrong. If this thing's giving me the wrong answer, I got to figure out why it's giving me the wrong answer. Compiling just means the code, the language of the code makes sense. But so if I'm saying an English sentence, saying a grammatically correct sentence would be like compiling code. Saying something meaningful is completely different. I could say, for why you throw my child down the stairs a cookie. The words are right. The content of how you're interpreting the sentence is very different. So debugging is making sure it works the way you expect. Compiling it means you're making it so that it can become a program. Find some of the tutorials assignment 2. Am I being able to do that? Don't share your code, but you can talk out the concepts. So you can talk about the concepts. That's not a problem. Ask them to talk to us. We're bored. We want to talk to you guys. I know I'm busy right now, but we do want to talk to you guys. But you can talk out the concepts. In fact, that will help you. You just can't show them your code. Because if you show them your code, unfortunately, we have lots of experience where they just take the code, even if they say they're not going to, they'll take the code, pass it in, and then you get called into an academic integrity violation committee. Honest to God, I did it last year. Yeah. All right. Okay, guys, I have to go right now, but thank you guys very much for showing up to this. I'm making sure I'm going to do this every single week, normal time for the lectures. And just, I will be online and answering your questions over the next couple of days. And Janae is right there on Discord right now, by the way. All right. Thanks, everyone. I will talk to you soon. Thanks.